So let's look at the 4 on these. I'll just, there we go. Zoom this in a little bit. There we go. Let's look at these 4, and I added a 5th bonus one just for extra fun. But let's look at the 4 that we're talked about on this page right here. How do I do these? Well, if they are perfect squares, you'll notice a perfect square minus another perfect square. That's the pattern that you need for difference of squares, okay? A perfect square minus another perfect square. If it's not a perfect square minus another perfect square, you can't factor it this way. This is a special case, okay? Let's have a look. When it is, though, it's very straightforward to factor. You get the 2 brackets, and you say, okay, what's the square root of y squared? It's y. What's the square root of 9? It's 3. Make one of the signs positive and one of the signs negative, and you're done. So it's a shortcut pattern. Okay? We can do that here with this one here. Okay, 2 brackets. 25m squared, the square root of that is 5m, because 5m times 5m is 25m squared. 16n squared is 4n, and 4n, and a plus and a minus, doesn't matter which one's which, and there you go, okay? So 25m squared minus 16n squared is going to be 5m plus 4 and 5n minus 4, whatever order you choose. Okay? You could have the variable in the back side, no big deal, as long as they're both perfect squares. And in this case, we'll go back to the red. In this case, they are the square root of 64 is 8. The square root of t squared is t, and again, a plus and a minus, right? And therefore, that's what you get. If you need to prove it to yourself, multiply it back and see what you end up with, okay? Multiply it back, see what you end up with. Okay? This one here, okay? Same thing. Just because it's h to the 4th, I can still take the square root of actually any even. Because h to the 4th, if I go off to the side here, the square root of h to the 4th is actually h squared, because h squared times h squared, if I do h squared times h squared, I have to add the exponents. 2 plus 2 is 4. In fact, this is a little aside, I can actually do the square root of any even number. Let's say this was h to the 10, okay? I'm going to say it's h to the 5. And why I'm going to say that is because I know that h to the 5 times h to the 5, when I'm multiplying, I add the exponents. That gives me h to the 10. So it works for any even one. It doesn't work for odd ones because you know, what is it? If this was a 9, that'd be a 4.5. I mean, it kind of works, but not properly. Okay? So having looked at this, h to the 4, I can say this is h squared at the front of both brackets, h squared. Okay? Now 16, the square root of 16 is 4, and I need a plus and a minus. And then I'm done, right? No, you're not. Because when I look closely, that's also a perfect square and a perfect square. So this one here, I could break down further. This one here, I cannot. I'm done with that one because of the plus sign. Remember, it has to be a minus sign. But I can say this is h, and this is 2 and 2, and I can have a plus and a minus. So this actually has 2 steps to it. Okay, 2 steps. Now this one here is the bonus one that I added. 5x cubed minus 45x, and you're like, why? This is not, neither one of them are perfect squares. But the very first thing you always have to do when you factor is look for the greatest common factor. And if I do that, I will notice that both of these can be divided by 5, and they both have an x in them. Right? So let's do that. Right? 5x cubed divided by 5x gives me x squared, and minus 45x divided by 5x is 9. X squared minus 9. Well, of course I set it up this way. But x squared minus 9 is a perfect square minus a perfect square. In fact, it's the very same as this one, only an x, not a y, right? Which means then I can go further. I got this common factor, and it looks like it's the same as that, only with x. And therefore I'm done. Okay? So a shortcut, if you see the perfect square minus a perfect square, but also keep in mind there's some more pieces that you got to continue to look for.